Welcome everybody. So we're going to be talking about data and its relationship to successful AI today. So firstly, I want to introduce Bernardo. Bernardo is a practitioner out there. He's one of the ones doing the magic that makes businesses successful. So I'm going to let him talk about himself. Okay. So Bernardo, tell us who you are, where you're based, what country are you in, and why are you here today?
I'm based in Portugal, yeah. So I'm a Portuguese working in Portugal, working for a company called Molly, a payment service provider. I've been working in data science for the past 10 plus years. And yeah, with data engineers and analytics engineers, data governance people as well. So I've been exploring a lot of the data space and super excited. As you were saying, I'm a practitioner, still like to get my hands dirty and love building a good machine learning model, especially the classical ones, so not the fancy ones. And I still love it, and I still spend a lot of time doing it.
That's great. I used to be a practitioner, and then I think I've gone to the dark side. I'm with a vendor now at the moment. So I've been doing data science also for well over a decade. It depends on how you count it. I mean, we might be heading towards 30 years now. I built my first neural network back in the 20th century, and I'm feeling very old now when I say that. I'm based in Singapore, but I'm not a Singaporean. I'm from Australia originally. I've been living up here in Asia for more than a decade now. And I have been a practitioner. I have been working for vendors. I've been a hands-on data scientist. I've been a marketer too. I went very much to the dark side. But I still keep my hands on. I get involved in the latest things that are out there. I like to actually do things. And so, as I said, we're going to talk about the secret to AI, great data. And the format we're going to follow is just a chat back and forth between Bernardo and I. So let's start with data and data sources. You've got to start by grabbing some data. So Bernardo, how much of your data is structured versus unstructured?
I think you can already guess some of it, right? So I was saying I love classical machine learning, and so I'm pretty much into structured data. It's almost always structured data in enterprise scenarios. So I would guess, yeah, above 95% of it is structured. We do have some voice, we do have a lot of text as well, but like the main data sources driving value are structured ones. There are tables that are managed by our internal and some external systems that we then fetch, get together in our data lake, then process in order to build features and then build the models. So yeah, most all of it is structured.
Are you planning on using any more unstructured data in the near future? Like, do you want to use ChatGPT for text? Do you want to generate any images?
So we obviously are going to use more unstructured data as we go forward, definitely. But it's still quite clear to me that the immediate value, and there's still a lot to do with structured data, and there's a lot of things that are directly connected to what we're doing at Molly. Again, we're a payment service provider, so we're mostly offering payment services, and that's structured data heavy, right? More than anything else. Yeah, we do some sort of customer service, so we do have some voice, people are calling us, we have some text, documentation, we have, again, customer support, we have contracts, so there is some text and some voice and some images involved, but the majority of it is structured. And if I look at my my future use cases, the ones that are waiting for us to have more time to dedicate, they are almost all of them around structured data. Even though I can admit we're also exploring ChatGPT and other recent advances in AI.
What part of your data do you think gives you the biggest competitive edge over other payment providers?
Yeah, as I was saying, like the competitive edge mostly comes from our internal sources, right? So it's mostly things that we generate and that we are collecting and gathering. And most of that is data that we collect through our APIs and through the hosted components that we offer. And almost all of that is structured. Some of it is like logs and some nested structures of API calls and those kinds of things. But the first step there is converting that into structured data. So it's not that we're using a lot of deep learning models where the unstructured data directly is fed into the models, like images or voice. Most of the times, there's this intermediate step where we have to take data in its original form and transform it into features that we then feed into the models.
So one of the issues I've always found with tabular data, I love tabular data because it's the most challenge. And the very first challenge I always have is, what is in this table? What does this field mean? What does this value mean? Or this silly code? How do you manage that knowledge part of dealing with tabular data?
So I'd love to say that there's a silver bullet to dealing with that, or that there's an easy answer. I think the real answer is most of the times, if you're a practitioner, you know, most of the times there isn't a lot of data documentation, especially if you're dealing with raw data. We do have people whose main job is basically structuring data and creating data models to basically democratize the access of data. We call them analytics engineers. They're building data models that then the business analysts and data analysts are using. And so we do have a subset of data that's highly governed and that has a very strong semantic layer on top of it with descriptions, with allowed values in the columns. But that's a small subset of the data that we're using. If we go and look into all of the sources that we have available, we have a lot of them that we're extracting and loading, so following the typical ELT pattern, and that don't have a lot of documentation around it. And for that, the answer is still diving into the data, exploring, talking with the producers, trying to make sense out of it, building some plots, exploring, trying to understand the meaning. So that's why it's still, in a sense, it's still a craft. You have to know how to play with data, how to explore it. Obviously, if we are careful, and we are at Molly, the columns have sensible names, so you can actually guess some things out of the names as well, even though that's a bit dangerous sometimes. But there's a lot of back and forth between producers and users of data in order to understand the semantics and the actual content. And there's a lot of value in understanding how data is produced, so the process by which the data gets into a given table, and usually that has a huge impact into how much value you can extract from it. So even if you have very good documentation, even if you know the description of the column, there is a lot of value in understanding the system that's generating your data and how it's being used. So in a sense, it's still an art, getting to understand what's in the table, what's in the column, what does that weird value mean. There's a lot of value in spending a significant portion of your time in those questions, I'd say.
So there's been a lot of hype about ChatGPT and similar technologies making data scientists obsolete. What I'm guessing you're not on that side of the hype there.
Yeah, I'm not, and to some extent, what we're seeing is it's a great tool. It decreases efficiency in a lot of scenarios. It's not at a point that it can replace any of the jobs that we're talking about, even the ones that are more directly connected to generating text. So even in those scenarios, we're seeing a lot of hallucinations, a lot of problems with truthness of what's being created. But I'd say that for data scientists, it's more than that. I think that there's a place for ChatGPT or equivalents to help with increasing developer experience and developer efficiency. So if I'm building code, if I'm writing Spark code, and I can't remember what's the syntax for doing a window function that's super complex, I think there's value in asking ChatGPT specifically. Probably I could get it as well from Stack Overflow, I'd argue, but there is value, and I'd say that there are scenarios where building those things is useful, or building regex, for instance. It can help a lot, and it can be a great accelerator. Yeah, I see I've touched a sensitive point. But there are some things where if you are writing code, ChatGPT can increase the efficiency. But there's so much value still in things that are not just writing code, in understanding and getting understanding of the actual data that you have in front of you. And with almost total certainty, ChatGPT, when it was being trained, wasn't exposed to your own internal data, to your own internal documentation. So the probability that it understands your sources better than you do is super low. So there's, as I was saying, data science is still a craft. There's still an art component to it that you need to understand. You need to be able to develop that intuition. And that's something that is still super manual and context dependent. So I'm not seeing ChatGPT in the near future being able to replace that for us. It has a lot of good things, a lot of benefits, but not exactly at replacing data scientists, I'd argue.
So for your team, what do you think the split is between writing code and tuning algorithms versus spending time with the business and learning?
So we've all heard that 80-20 split of data prep and then model building. I wouldn't say that's exactly the case, and I definitely argue that it should vary with the maturity of the team as well. So the data science team at Molly isn't that old, so we're still in the early stages of building the initial features, initial entities, and all of those things. So there is a lot of work in exploring data and creating those entity views of the data that we have. So for now, I'd say that a very significant percentage of it is exploring and modeling data, and then the actual modeling and tuning doesn't take a huge part of what we do. That's true for the time being. I obviously expect as time goes by that we spend more time extracting as much value as we can from the model tuning and the actual architectures and model choices that we have. But my main experience has been that usually you get much more value by building better features and exploring your data better than just trying to optimize hyperparameters in your IGVM model. At least in the early stages. Like if you have extracted as much as you can, then obviously there's value in trying more complex model architectures and trying stacking and ensembling and all of those things. But initially, and I'd say that this initial period can actually span several years, you can get much more value by just modeling your data in different ways, extracting different signal types from your existing sources, understanding, as I was saying, how the data is generated, having chats with your business stakeholders, understanding the heuristics that they use when they're manually analyzing the data. There's so much value there that my heuristic is that if I have a week to spend, I'm going to spend 4 days talking with people and exploring data before I spend more time tuning and trying to do hyperparameter optimization.
So talking data, how did you design your data stack to balance out the competing requirements? You've got the need for security and privacy, you've got the need for stability and scale, and you've got the data scientists clamoring to get access to as much as they can get. How do you balance all those people screaming at you going, I want this?
With some pain, I'd say. But yeah, I'd say that the way of managing those trade-offs is not to make a choice that you're going to be only focusing on privacy or only focusing on experimentation, but exposing different parts of your stack to different people. And so having this vision that the different components that are part of your stack need not be used by everyone in the same way. So for instance, we do have the CLT approach mainly. We're actually shifting a bit of that into the producers as well to give them a bit more ownership of the data they are sending to us. But if we are doing this extract and load into the data lake, we obviously are collecting a lot of data. Some of it is sensitive, some of it requires some privacy measures. So we spend some time on the platform perspective, making sure that we're classifying data and protecting data and anonymizing data so that we can then offer as much freedom as we can to the data scientists. So instead of saying that we are closed by default and that data scientists need to request access to a particular table, which obviously doesn't work because they have no idea of what they're going to need. Like the answer, how much data do you need, is always as much as I can, right? The data scientist will never tell you that I don't need that table, I don't need that amount of history, just 1 year is enough. You're never going to hear that from them. So I think that the solution is mainly understanding that you cannot expect them to say in advance what they need. So they're going to need to have access to raw data. They're going to need to have access to as much tables as they can. So you should make sure that one, that data scientists understand the conduct that they should have when working with data, but at the same time that by design you're protecting sensitive data in a special way and anonymizing when needed. But my main approach is to be as open as possible, especially to power users like data scientists that know what they're doing, and to provide them with data in its rawest format as I can, because there is so much that you can derive by exploring data in the way that it was generated. Once you start doing some aggregations, once you start cleaning data, most times you're at the same time losing some value. And so data scientists need to be able to access data in that format. But as I was saying, some users need more guarantees, they need more governance, they need more semantics to explore data. And so we also offer them that. And that's why I was saying different components for different people. So we have our lake with raw data, but then we have like the medallion architecture, the bronze and the silver and the gold layers that have obviously less data. So it's a subset of data, more aggregated, more semantics, more guarantees. And that's the layer that's used by analysts and by business users and stakeholders. So the tension is solved, or these tensions are solved through exposing the platform in different ways depending on who's using it.
So it's interesting you talk about, no data scientist is ever going to say that they don't want more data. The other constant you're going to get from a data scientist is no data scientist is going to say that their data is good quality. No one out there says we've got great quality data. Well, no one honest, I've got to say. Tell us about the most frustrating data quality problem you've ever come across, or maybe more than one. I'm sure you have a few war stories there.
A lot of scar tissue with data quality issues. So you'll find everything. I think the funniest ones usually are the way that missing values are encoded. So things like whenever you don't have an end date for a contract, someone decides that 31st of December of 29.99 is a good date to write there instead of just leaving it blank. That happens quite often. Something that frustrates me tremendously is when people decide that I don't need history and just overwrite a given row in a given table. So something that happened quite frequently, like we only need the customer's current address. Why should we need the previous addresses of the customer? And usually that becomes a data quality issue itself. Categorical features are quite often a problem. So you have, for instance, 3 types of customers, but then suddenly a given executive decides that you want to add a 4th one, or maybe rename them all. And so you're modeling a given data set that has some values in a given column until 2021, and then after 2022 you find something else, and then the values don't match at all. All of those things are different quality issues in a sense, or at least data quality problems from a data scientist perspective. If you speak to a data engineer, they'll say, I'm ingesting data as is, so there's no problem there. I'm not corrupting any data, so there's no problem here. But for me, for modeling, these are quality issues. And not even going into like free text fields where you have misspellings and those sorts of things, because whenever I see text, then I'm expecting as bad quality as I can get. But for fixed fields, I still get some surprises. Now I can laugh about some of them, but I've wasted hours and days trying to solve some of these issues, or even trying to diagnose them and to realize that they were there.
Based in Asia, I'm dealing with a whole bunch of countries here where English is not their first language. And it's funny you complain about categorical data. Text is worse. There's text that should have been categorical. That's one of my absolute 2 hates. I'm going to start with this one though. And I had to deal with a motor insurer. Do you know how many ways they spelled Toyota? It was more than a dozen different misspellings of Toyota. And going through and trying to clean that, because you can't analyze the data for motor insurance if you don't know what sort of vehicle you insured. And it was just, so this comes back to the producers and trying to get them to realize that some of what they do is creating problems downstream. And my other absolute pet hate is a data type, and that is dates. Dates are always the worst data type to ever use. You've got US dates, which I'm going to insult all the Americans, are just crazy. Why would you mix up the order? Then you've got other types of dates, your ISO dates. And then here in Asia, I've got a completely different calendar system at times. The Buddhist calendar is more than 500 years ahead of the Gregorian calendar. And so I look at that and going, is that a typo or is it a Buddhist date? Why are there so many digits here?
And then you have time zones to complicate things even further.
Oh no, and time zones change all the time, and they don't even follow nice things. Coming from Australia, I grew up in Sydney, and Sydney's part of the state of New South Wales. New South Wales has a time zone, except if you live in far western New South Wales, in which case you follow South Australia state's time zone. And where that border is, damned if I know for the time zone. It's not the same as the state border. So given we've got all these data quality problems, who should be handling the data quality? I just mentioned that there's some responsibility with the data producers, but how willing or ready are they? What about the data engineers? What's the role of the data scientists?
I think that's a very difficult question to answer. And I think that probably the best one, but the hardest one to hear, is that everyone is responsible for data quality. So you cannot just assume or trust that someone else has taken care of that for you. It's in the same way that in security, you have those zero trust policies where you trust no one, you trust no device. I think that we need to have something similar for data quality, like zero trust data quality, where you always assume that there could be some issue, especially because different parts of the data producing workflow will have different definitions of what data quality is. And so you were saying to some extent data producers are responsible, definitely. And so if you have a field that should be a fixed field with a fixed set of values, like one for Toyota and not 20 different spellings for the same thing, then obviously that's on the producer's system responsibilities to solve. If the schema keeps changing without them realizing that you're depending on a given column for training a model, there's also an issue there. So one of the things I'm working a lot is making sure that there's very strong collaboration between data scientists, data engineers, but also software engineers that are owning the source systems and building some contracts in place whenever we're depending on given tables or columns for building models. Or even shifting the way that we're loading data. I was talking about ELT systems where they have their own tables and I'm going there and extracting data out of them. But probably that's not the best approach. Probably they should own the producing side of things and saying, here's a new event that I want you to know of, and I'm going to send it to you. And so it's much more explicit and much more formal, that relationship between us. So in a sense, producers should own it. Data engineers should own it as well, in the sense that they should make sure that the data that they are collecting is complete and is the true data that's being generated by the source system. In all of these examples we were giving, like a data engineer would say, I'm just writing things as they are at source. So if there are 20 different spellings for Toyota in the source system, I should load them as is into the data lake. Is there a problem with this data? You'll only know once you start exploring it. Once you start getting some business context, you'll know, because you know how to do insurance, you'll know that having the brand of the car is one of the most critical things. And so you cannot live with 20 different spellings for Toyota, but the data engineer has no capability of knowing that, or a typical data engineer that doesn't know exactly the business context that the data is going to be used for. And so each part of, or each party in this process should basically analyze the quality of the data for their own purpose. It's great if we can then share the same language and if we can help each other. So if I, as a data scientist, I can explain to my software engineers, my colleague software engineers, that they need to keep that column with that format because I'm using that for training a machine learning model and making it explicit, then all the better. But as I was saying, in my experience, in like the scar tissue I have, I always double check that the tables I'm using have the schema I was expecting, that the categorical columns have the values I knew when I was training, and that I get no surprises at prediction time with new values appearing. I always make triple sure that the dates I'm using are UTC dates or equivalent. So those things you were saying, I always check them, and I build some sort of data quality tests at the beginning of my pipelines. Obviously, that creates a bit of inefficiency because that's an additional layer of overhead I have to have when building a model, but it's the only way to make sure that I'm building high quality models that generate valuable predictions. Otherwise, we're going to get troubles.
Do you have a standard way of documenting or communicating the data rules between the three groups that we just mentioned?
We're trying to make it as technical as possible. So implementing these contracts with technology. So making sure that whenever we're ingesting a data source, we have some quality rules that we're checking, and we're allowing data scientists to contribute to those rules as well. so that we're all committing to the same standard of rules being applied and being checked at runtime. And whenever we have failures, those generate alerts and we all see them. And sometimes the alerts are, I couldn't connect to the source system, and that's something that the data engineer will check. Sometimes they are, there's a new value here, or the distribution for the amount column is completely different than it was yesterday or a month ago. And so we're trying to be technical in the way that we approach data quality and not rely on documentation or writing text, but writing code. Though, like with ChatGPT, the distinction between text and code is blurring a bit, but let's forget that for the time being.
Okay, so we just talked about who should be handling the data quality. Who should prepare the data for AI?
So for that question, I have a bit more blunt, I'd say. So for the other one, I was a bit vague and saying everyone should handle it. I'd say for preparing data for machine learning or AI, it has to be the data scientists. You cannot delegate that to people that don't have the proper business context. It's not that they can do it, it's that the way that you, or the things that you need to know when building features and preparing that data require a lot of business context, require a lot of knowledge of what that data is going to be used for. So if you know what you're trying to predict, if you have some heuristics that you got by talking with business stakeholders, by operations people that were doing it manually before you arrived, those are the things that inform the data that you're going to look for. So sometimes you don't even know what tables exist, and you have to look for those data sources, but you have some intuition that it would be great if you're building a propensity model for something. It would be great if you had the table that described the products that the customer has, or some demographics about the customer, and then you go looking for them. And so, and the way that you then model those features, and the way that you then model that and create features out of them, requires knowledge of what you're going to use them for. And so I haven't seen in my career a way of delegating that to anyone else. I don't think there's value there. I think that part, as we were discussing at the beginning, part of the value that the data scientist brings is bridging that gap between a business problem, a data problem, and then modeling data in such a way that the model can derive value from it. If you're taking that part of modeling data out of a data scientist, you're limiting tremendously what they can build. If you're only saying, like, here you have a data warehouse, here you have 100 features that a data engineer or an analytics engineer has pre-built for you, with some pre-aggregations that you have here on the customer level, you're losing so many signal types that you could extract from raw data that are not useful for anyone else.
But I ask you, what do you mean by a signal type? Because I think that's a new concept for many data scientists.
Yeah, so when I say signal type, I mean a type of feature, a type of meaning that you extract from data. So if you're thinking, for instance, you have, I'm working in payments, right? So my main table is a table of payments, where I'm saying at a given point in time, there was a customer that made a payment of this value and bought this, for instance. Well, these are a bunch of tables, but the main table is the payments table. Now I can extract a lot of things from here. A typical thing would be, just let's count in sum how many payments each user made and what's the total value. That's something my chief commercial officer would do. Yeah, but then we can start to think, I want to know more than that. I want to know how frequently a given customer purchases something. I want to know what's the recency. So how long did that purchase happen? How stable are they? Do they usually make the same amounts each day, or do they vary a lot? So is there a lot of entropy in this signal as well? So yeah, recency, similarity, for instance. So how similar is this purchase to the ones before? Similarity, stability, recency, as you were saying, all of these things are different ways of modeling the same data. How much time between purchases is a different way of looking into this. And all of these are different signal types. Am I looking into stability? Am I looking into similarity? Am I looking into, recency? All of those things are different ways of modeling the same data, are different ways of aggregating it. That's why starting with an already aggregated table is going to make you lose a lot of things. So you need access to the raw payments table to be able to create all of these features. Otherwise, you're severely limited. Obviously, you can do something, but you're not extracting as much value as you could from the data that you have.
Yeah, so that's going to require a lot more access to data. You won't be able to have a single table for example, typically. You're going to have to look at one-to-many relationships. Some will be one-to-one, some will be many-to-one. That's a lot of access to data. Now, you mentioned that you anonymize personal information. What personal information would you anonymize? Would you anonymize address or date of birth, for example?
That's a great question. It depends a lot on, one, the use case. So one thing is if I'm building a fraud model or an anti-money laundering model where I'm going to use as much as I can, and obviously I have permission for using data in its source format, it's something totally different than if I'm doing something with for marketing purposes, for instance. So right now at Molly, my life is a bit easier because we're B2B business, and so we don't have a lot of personal information. I used to work for banks and telcos before, and there you have tremendous amounts of personal information and very sensitive information. And the amount of anonymization that you do is always a tricky subject, something that you have to spend a lot of time negotiating with your data privacy officer and with your compliance people, because obviously if you anonymize an address completely, then you cannot do anything with geolocation, right? So perhaps you can say and take like a differential privacy approach where you're going to say, as long as I have at least 10,000 customers or 1,000 customers, or the threshold depends on your company and the sensitivity of the business, then it's fine. So maybe I cannot use the full address, but maybe I can use a parish, or maybe I can use just a city. So the level of anonymization that you do depends a lot on how sensitive the data is and how identifiable that field is as well. So it's a tension, and the concept of differential privacy and not anonymizing everything at the same level, but applying different levels of granularity depending on how identifiable a given field is something that I've spent a lot of time in. That makes obviously the data science work much harder, but it's definitely needed. Again, I prefer to do that and to have those conversations and then to keep access to data in its rawest format than just to say I'm going to aggregate everything, and so everything that's not aggregatable, not summable or countable, you just lose it, right? And that's obviously a much bigger problem for a data science team.
So how are you making data access more self-service? Do you use tools for that, or is it carte blanche? Is there any controls around that?
There are controls, but it's mostly role-based access. So what I'm saying is, like, for the data in its rawest format, so without any sort of transformation, you have a very small set of people that can access it. And then once you start removing personal information, once you start to classify data and understanding how sensitive it is, you can start opening up. And then data scientists would be at this level, for instance. They would be able to access data in raw format after removing sensitive information. If you then want to provide access to the entire company, perhaps you have to be a bit more careful than with the previous level. So just sharing aggregates and sharing pre-filtered tables with some context, not only because it's sensitive, but because if you're providing data without context, then the probability of them making wrong assumptions about that data is huge. And so data access is not only a matter of protecting your data, which is super important, even though my philosophy is to try to be as open as possible. If I believe that the business should be data informed more than data driven, but that's a subject for a different conversation. But you need to provide access to data, but that also requires very strong governance and to approach governance in a smart way. So not saying, our approach to governance is saying everything is locked and you have to ask for permission every time you need access to something, but to be proactive about how you do governance, about how you classify and protect your data.
So you've got a good process, you've got data scientists getting the right level of detail. How do you approach feature engineering that raw data? Do you start with generic features, or do you start from domain knowledge inspired features?
It has to be a mix of both, right? So, and especially as time goes by, my experience tells me that some features are highly predictive in a variety of scenarios. And so it doesn't make sense to start from scratch every single time. So once you start creating some descriptions, so some rich descriptions of a customer or of an account or a vehicle or something else, it makes no sense to approach it from a blank slate every time you start a new model. There are some descriptions that are useful. That's why I'm a believer in feature stores, because in a sense, features that you use for one purpose can be reused for other purposes. So we always start, and as time progresses and as we get a richer set of features, we have a better starting point. And one thing I love to do when I start building a model, one of the first questions is, do we actually have enough data and enough signal to predict what we're trying to do here? Sometimes we'd love to understand what's going to be the conversion rate of a new offering, and we have no data for creating that model. So one of the first things I like to do whenever I start a new project is just to take the features I already have and to build a very simple model and to see whether I can get anything out of it with some simple metrics. If I see some signal there, if I see some potential there, then I move on to the next stage, which is actually understanding the business problem, talking to the people that have been doing that manually, if they exist. So if I'm doing a propensity model, talking to salespeople and trying to understand what are they looking for when talking to a customer or when looking into a given profile or a given company, what are the signals that they are trying to capture, what does their intuition tell them, and then convert those into features. And a lot of times those features are super specific to a given model. I remember being, you mentioned auto insurance, building that product for a bank, and the features that we're using for predicting whether a given customer would need auto insurance were super specific for that particular model. So if I was trying to apply that for a mortgage model, I would get nothing. So some features are super specific, some features are very generic. The way to manage them and connect them to the entities that make sense, so the way that you organize your features is very important, because otherwise you're going to end up with a bag of features that's huge, and then you're going to spend a lot of time doing feature selection, which is again manageable, but not ideal. I'm not a very strong believer of just throwing everything you have into a model and then letting it figure out how to do things, especially if you have some sort of expectations on explainability and interpretability later on. So this approach to being smart about how you do features for me is super important.
I recently spoke to a telco, and their feature store has more than 10,000 features in it. And they weren't bragging when they said that. They were asking for help. This is too many. How do we manage it? And it's interesting that you talk about signal types, that you talk about entities, because that's the way we at FeatureByte think about it. You've got to have some categorization of your features so you can search, find the ones that make sense, find the ones that have the right entity level for your use case. So while we're on features, what is your favorite feature engineering trick?
I have a lot of them. I think that the one that made me feel the smartest when I first described it, like first year as a data scientist or so, was how to transform time. So again, I was building a marketing model, and I wanted to predict the probability that a given campaign would be successful, like the conversion rate. And I was trying to understand the time implications of sending a push notification or an email in that conversion. So the first thing I did obviously was split the timestamp into several components. So year, month, day, and then hour and minute, which is all nice. But that for a model. So if you're distinguishing what happens at 11:59 p.m., what happens the first minute after midnight, for the model, they are completely separate. So you're requiring a lot of computational effort in order to realize that they actually behave quite similarly, because in reality, they are the same. So the first time I realized that you could actually do some sort of transformation, in this case, doing a sine and a cosine transformation of the timestamp. So capturing that cyclicality of time was super mind-blowing for me, and I was super proud of having that idea. Then I realized everyone was doing it, and I felt less smart, but that's part of my journey of becoming more senior as a data scientist. But I really like that approach of transforming features in a way that captures reality. So not being, not just applying transformation. So I've seen some approaches where you're just like multiplying dates by currencies and dividing amounts by, I don't know, like all of the weird combinations of just trying brute forcing feature creation. And I hate that approach. So any transformation that captures reality in this sense, this example is great, because two things that are 2 minutes apart in reality should be 2 minutes apart in the way that you model the feature. For me, are the most interesting ones.
My favorite is another one that's actually not used very often, but when you think about it, it's quite easy to implement. I like to go and either in a table or in a feature list per row, count how many missing values there are. And people often just look at a single column and go, oh, I've got to do something with the missing values. But if you count them, you're basically relating back to the cold start problem. If I got a lot of missing values, it means I don't know much about this entity, and I need to treat that entity different to one that I know a lot about. And it's incredibly simple once you think about it. Yeah, but I don't see it happen very often. And when I do use it, it's typically quite powerful.
You're basically allowing the model to use that as one of the most important things, like almost building two different models or a number of models depending how much you know about that data. So it's super smart.
Yeah, yeah. So we're getting onto feature lists now. How big are your feature lists?
Obviously, I'm going to run away from giving you a number. Otherwise, you're going to criticize me in the same way that you're criticizing Metallica. We're not in the tens of thousands, obviously. And again, we started quite recently. I don't like to think of it as like raw number of features. I prefer to think of it as like the variety of signal types I have per entity, as we were describing. So if I'm just taking the amount of a given payment and I'm creating mean, mode, median, obviously the correlation is going to be huge, right? They are three different features, and you're going to be super proud of yourself because you've built three features at once, but the signal there is mostly the same. So you're not adding a lot of value. I'm much more interested in the signal types we were describing previously. So we are starting, obviously, with small feature sets and being smart about the size of our feature lists, making sure that each feature that we're adding is sufficiently different from the rest that we have. But obviously, in doubt, we keep more than once, right? So if you are not sure if you're adding enough value, like gradient boosting trees know how to deal with correlation of features. So when in doubt, I usually keep them, but I'm fairly strict then about trying to prune the models I'm building. I'm not usually in the position to then take things out of the feature store. Maybe that's something interesting to explore, like features that are never used, should they be there, just complicating things. That's something interesting to explore. We're not doing that yet. So we're basically just being smart. Whenever we have strong evidence that a feature is useful, we just add it to our feature lists.
Okay, so let's balance this out. Tell me about a time when feature engineering went wrong.
Ooh, how much time do we have?
Just only one time, please.
Yeah, so many stories. Like, I think that the hardest thing about feature engineering for me is managing the time component, right? When we're doing Kaggle, everything is already a feature table, so everything is taken care of. When we have all of these relationships between different tables and things that were captured at different points in time, it's super hard to get them right. I think that one of the most frustrating experiences was when I was building a model, a propensity model. Again, I keep on giving marketing examples for some reason today. But we were building a propensity model, and one of the things we realized was super important and super predictive was the household size of a given customer. So how many people were in their household? And it was super predictive. And once we started to look into it, obviously we had tons of explanations for that. Like the larger the household, the bigger the need. Once we started to play with interpretability and exploring the actual correlation, it was just the fact that the feature was filled in, if it had any value or if it was missing a value. And then we realized that it was not actually a feature because that value was filled in as part of the application for buying the product. So whenever it was filled in, it meant that you had started to buy the product. This was for a bank, so the buying process was super long. And so we thought it was a feature. It was actually the target. We were encoding the target as a feature because we were not handling time correctly. We were not looking into when that value became available in the warehouse. We were not thinking about when data becomes available for modeling. We were just assuming that this is something that describes the household, so it must be there for every customer since the beginning of the customer relationship, which is not true. So it made me super aware of understanding when data arrives and how it's generated, because that's super important for actually building good features and not inserting leakage everywhere.
Yeah, I've actually got a very similar war story. I was doing something for an airline, and their model, feature importance, told me that the distance of the customer to the airport was the most powerful thing to predict whether they'd respond to a marketing campaign. And I'm going, that just doesn't make sense to me. You know, it was way overpowered their income, their flight history, their age, their gender, the whatever. Yeah. And it turned out it wasn't really the distance that mattered. It was just, was there a distance?
Yeah.
Or what person was missing? And for the same reason, if they'd never responded to a marketing campaign, you didn't know their address. Therefore, it was a missing value.
Yeah.
So we're almost finished. I'm going to ask one last question before we open up for questions. What do you think the biggest challenges are for deploying data pipelines for AI systems?
So we've discussed who should own feature preparation. We haven't discussed who should own machine learning deployment. I think that the distinction between the data scientist and the machine learning engineer should be interesting here as well. But to try to summarize, I think that some of these issues, for instance, differences in implementation of features in training time and then serving time. So are you using the same system, or do you have a different source for your features depending on whether you're training the model or serving it? And a lot of times you're using different systems, so you're not going through the data platform or through the data warehouse to serve the model. And that means that you have slightly different implementations of the same features, and that usually results in worse models. And so that's one of the things I try to avoid doing, and I try to have the same source for training and for serving. I connected to the example I was giving, again, being mindful of feature latency. Not every feature becomes available at the same time. And sometimes some features only become available after the fact. So they're actually labels or targets. And being mindful of when data becomes available is super important. Usually that's abstracted away when training the model, but it's super important for deployment. If data isn't there when you need to make a prediction, or at least if it's not in its final form, then you have to replicate that when training the model, because the model has to be trained in the same circumstances that it will be used for.
When you talk latency, you seem to be mostly talking about freshness, but what about latency in terms of calculating a feature? Some of the more complex ones, so if you do a cosine similarity on two sets of events, could be quite time consuming. Do you ever throw out a feature because it takes too long to calculate?
Oh, definitely. In the same way that we throw out some models because it takes too much time to predict something. So yep. Again, that's not yet completely automated. So in a sense, we have to be manual about how we measure the time it takes to compute a given feature. But that's something that we're super mindful. If we're building a fraud model that we have to give an answer in millisecond time, we cannot afford to do something that takes 1 second to compute. So definitely, yeah, freshness on the one hand, but latency as well. Two different concepts, but both important. And my final one would be like drift in features. So features that change distributions over time. And so when you're training a model, you expect the feature to behave in a certain way, but then your consumer behavior changes. And so the feature changes as well. Yep. And your model hasn't seen that in training time, and so starts to behave badly. And so this feedback loop between the features you're training on and you're serving on and retraining the model, whatever that breaks, is super important to be mindful of.
All right, so what I might do now, we've got just a little bit less than 10 minutes left. I want to open things up for questions. So there's none there at the moment. I'm hoping people will post some. While people are posting their questions, I do want to just say I'm from FeatureByte. We are just about to release an open source package that deals with many of the issues that Bernard and I have been talking about, that has signal types, that has semantics for data and leads and is very entity focused, that you can search your feature store via these things, that deals with latency, that blind spot we were talking about. If you'd like to sign up for early access, I have a link here.